Okay, so let's talk about question 1982. This is more something like I would expect on the AP exam now because it doesn't require calculation. You would be able to type it into some kind of a web browser fairly easily. I don't know what that exam is going to look like yet. I think we get more information early in April. And as always, as soon as I get it, I'll give it to you. So the question says, from the standpoint of KMT, kinetic molecular theory, discuss briefly the properties of gas molecules that cause deviations from ideal behavior. So there's really two things we're looking at. And the first is we assume that gas particles are zero volume. And so this is a problem because when we start compressing them, that volume that the ratio between the volume of the container and the volume that the particle takes up gets higher for the volume of the particle, and so they start to interact. And the other deviation for real gas is that they exhibit some attractive forces between the molecules, and so this would lead to collisions that would cause the molecules to possibly interact with each other, and then they could go from the gas to the liquid phase or something else, or make them have fewer collisions with the walls of the container. And if they're not having collisions with the wall of the container, then the pressure would be lower than we expect it to be based on the number of moles of that gas. Part B says, at 25 Celsius, 1 atm, which of the following gases shows the greatest deviation from ideal behavior? Give two reasons for your choice. So I'm looking here for something that has the biggest size, and that would be SO2. And so that addresses the first one, is that it has the largest size or volume of the four gases listed. And the second one would be it also has the highest intermolecular forces, IMFs, and it has not only van der Waals, which all of them have, because every molecule has van der Waals, but they also have dipole-dipole interactions, which would cause them to have some attraction with each other. Part 3. Real gases approach ideality at low pressure and high temperature, or both. Explain these observations. So here they're not asking you to tell them what the observation should be. They've already told you. So go with it. So let's deal with them one by one. At low pressure. At low pressure, the molecules would have the most distance between the individual molecules. And so their volume relative, the volume of the particle relative to the overall volume is smaller. The second part is at high temperatures, we have higher kinetic energy, and that means they are easier to escape the attraction of the other molecules. So I hope that's helpful for you. Let me know. I have another video to go over, and these should post sometime on Sunday. Thanks.